Constructions, the 11th chapter of the syllabus. Let's see what is the essentiality for discussing about constructions. Construction, the word which comes mostly when we strike with construction, we strike in real life with construction of buildings, construction of bridges, and construction of roads. What is this construction? So let's see in brief about what construction means in the mathematical sense. Today's session is about constructions connected with the branch of mathematics. Before we get into understanding construction in detail, let's get into introduction of a real life situation. So for example, I have a bridge. This is the bridge along which I would like to construct a support. As you have here, the bridge has the support in either sides, but it needs to have a support in the middle. So my situation in case of this bridge is about identifying exactly the middle point of this bridge where I can construct a middle point. So in order to find, an engineer finds that in order to build a pillar exactly in the middle, he needs to measure the midpoint of this distance AB. Such a situation in which the end of the bridge on the left is A and the end of the bridge on the right is B, which is a line segment AB at which the engineer would like to build a pillar exactly in the middle of the bridge. So here I have the bridge problem. This purely needs the knowledge of construction. An engineer proudly uses mathematics, that is, the topic of constructions in such real life situations. How do we make the pillar supporting the bridge in the middle? Because we all know that if we have all the pillars supporting down, then the heavy vehicles passing on the top would stand with the hard concrete of the bridge, or else the bridge would fall and collapse on the ground, making more damages and casualties. Therefore, an engineer, while constructing this new bridge, is very cautious about using constructions. So here he takes the line AB and tries to measure the midpoint, which is at this point. And then he uses the three types of pillars and then constructs a bridge out here. So here is the bridge supported by the pillar exactly in the middle. That's how we understand constructions. But now the biggest question which comes is, how could the engineer identify the middle value or exactly the middle point of this length AB is the biggest question in constructions. We use this real life problem as a base to understand the topic of constructions. So let's see how the engineer has come successfully by building the three pillars exactly at equal distances so that the bridge stands perfect. A real life situation of a bridge which uses the knowledge of constructions. Constructions to be followed briefly. A student who learns construction in a regular class session needs to have the essential instruments which are essential for building up certain things, that is constructing certain things. So let's see what are the essentialities a student should possess as a stationery in order to take the topic of construction. So it is very important to note that essential instruments play a vital role in constructions, because if you want something perfect, you need to have some tools used out there. So let's see what are the tools used in order to make perfect constructions, just like the bridge in the previous session as an example case. So let's see the essential instruments. These essential instruments are also referred to as geometrical instruments. Geometrical instruments is what we note when we talk of essential instruments for construction, which are also referred as geometrical instruments. So let's see what are the essential geometrical instruments in the topic of constructions. Proceeded further. The first thing which I need is a ruler. Because ruler helps me in finding the straight lines or drawing the straight lines. For example, when I draw a straight line randomly, I may not get an exact line, but if I take a ruler and then draw a straight line, then we get a perfect straight line. A ruler drawn through a straight line as given here with the stick gives me exactly straight line, but this is said to be perfectly straight and this is said to be not that perfect, because this is randomly hand drawn and this is drawn through a straight ruler, is how we understand the basic introduction of the first essential instrument, which is the ruler. Usually a ruler has the measurements in each of its side, where it starts with 0, 1, 2, 3, 4, 5, 6, etc. up to 10, up to 20. And it has subgrids divided up to 10. So there will be 10 in number, which gives me millimeter. So here this length makes 1 centimeter, and each of the smaller lengths makes 1 millimeter. And the other side of the ruler has the measurements in inches. So here I have them in inches. 1, 2, 3, 4, 5, etc. So I have the measurements here in centimeters and here in inches, is how we understand a ruler basically with its properties. The first essential instrument in the geometrical list of instruments is a ruler, because it gives a perfect straight line, and a hand drawn does not give me a perfect straight line. Now the second essential geometrical instrument after the ruler is the compass. So let's see how the compass helps in construction of the perfect pictures or perfect diagrams. A compass out here. So what is the compass? So here a compass refers to a circle. What we have discussed needs to be perfect. Imagine I have a circle drawn by hand. I may not get a perfect circle. But if I take a compass and draw a circle, it would be exactly perfect. So if usually a compass is a fixed instrument, which is pointed, and then the other end is fixed with a pencil. So here I usually put a pencil, and then I can rotate through the compass. So here A compass usually has a pencil which can be put on the other side, and this is the pointer of the compass. And this is the pencil holder. And this here you have a screw which can be fixed accordingly. So the screw makes it fixed so that you can make it tight or loose. This string can be adjusted more tight or more lesser tight using the screw. So adjustment of the screw helps us in making the pointer fixed at one point. So I fix the pointer at this point, and then I move the pencil round depending on the distance I want to take. So this distance can be adjusted by the screw which is out here. So the suitable distance which we wanted can be adjusted by moving to and fro, and getting the fixed distance can be adjusted by the adjustment of the screw. And then with that distance, I put the pointer here and I put the pencil out here at this distance of suitable distance, and then I rotate the pencil out here, keeping the pointer fixed. Then I get a perfect geometrical circle. Construction of a circle is what is the significance of using a compass. So compass helps me draw a perfect circle or its arc. Any length of the arc is what I understand through the significance of compass. Compass helps me draw a perfect circle on its arc. Is how we understand the concept of the compass. A perfect circle which is obtained using the compass. Without a compass, the circle is not perfect, but with the compass, the circle or its arc is perfect. So the second geometrical instrument significant out here is a compass. The third essential geometrical instrument is protractor. The ruler, the compass, and now comes the protractor. Let's see the significance of protractor in the branch of constructions. Protractor. What is the significance of protractor? Just like the ruler has its significance in drawing perfect straight lines, and a compass which has its significance in drawing perfect circles or perfect arcs, similarly a protractor has its own significance. Let's see the significance of protractor in real life. It helps in drawing perfect and required angles. So here the significance of protractor is that it helps me in drawing perfect and required angles. Suppose I want to draw an angle of 30 degrees, then I have to use the protractor. So let's see how you can use protractor in applications of making certain angles. But before that, let's see how the instrument looks like. A protractor is usually a D-shaped instrument tool in which you have a center fixed and you have angles moving out here. So here we have 0, 5, 10, etc. is how each of the angles look like. And again, between the angles, I have 5 subdivided angles or 10 subdivided angles accordingly, so that everything moves till 180. So if I wanted to find, say I have here 10, 20, 30, or 10, etc., then I can make the desired angle. Say for example, I wanted to find a perfect 51 degrees. I have a line AB at which I want to make an angle of 50 degrees. So I put the protractor here and then I mark exactly at 50, and then I just draw the line from A to this. So by marking 50, I just join A and that point and extend, which gives me the angle 50 degrees exactly out here. So we can make different angles through the protractor, which usually has angles moving from here. And suppose I want to make an angle 30 degrees from B, I put the protractor out here, and then I have the other set of measurements which start from here: 10, 20, 30, 40, 50, and then I move here and then I make an angle, this, which is 30 degrees. So depending on the direction from which the angle is taken, that angle is taken on the protractor, which has two sides, one starting from here and the other starting from the left. So this is how it helps me in drawing perfect and required angles using the instrument called protractor, which is a D-shaped transparent instrument in geometrical set of list. Along with the three geometrical instruments which I have discussed, the ruler, the compass and the protractor, we also have the other set of instruments which are called set squares and dividers. So here set squares and dividers. Usually we use this instrument quite rarely, only when we need to take into consideration the special angles like 0, 45 degrees, 90 degrees, etc. And the dividers, which helps us in drawing two parallel lines. So these concepts can be understood more better if we can apply them in the problems when we solve. So these are the set of 5 instruments which are important in the geometrical instruments, starting with the ruler, the compass, the protractor, the set square and the divider is how we need to use the set of geometrical instruments in construction. One of the most important concepts in construction is that use always a sharp and a pointed dark pencil. It is not suggestible to use a light pencil because the visibility would not be clear. Hence, use always a sharp and a pointed dark pencil is one of the biggest note out here. Secondly, in constructions, we need to be careful that we do not overwrite on the construction. Draw the lines or points or arcs neatly and only for single time. Most of the students have the habit of overwriting and making it go beyond. So here, do not overwrite is the suggestion I would sincerely give to the students, because if you just draw a line and if you overwrite this in such a manner, then your point A and point B, which was actually here, because of overwriting, jumps here and This error of the difference gives the whole construction being wrong, may not be perfect. So do not ever overwrite. Draw the lines or points or arcs, whatever you take, neatly and only for single time. Do not overwrite them. So these are the two important notes which we need to take into consideration if we want to achieve a perfectly constructed diagram. Keeping in mind with these two important notes, let's see in each of the steps how to construct different diagrams using the mathematical properties to be followed with. Now that we have discussed about the essential instruments required for construction and the simple rules followed and the precautionary measures taken, that is to have a pointed pencil and a darker pencil, and about taking care of not overwriting on the constructions, let's see some of the mathematical constructions. The first thing about the construction is I want to draw the bisector of the given angle perfectly using construction. This session is about constructing the bisector of the given angle. Let's see how we can do that. To construct the bisector of a given angle, let's see how a bisector can be divided. I mean, for a given angle which can be exactly or equally divided is what we call the bisector. So let me take the angle out here. Here is the line segment AB, and here I have an angle made by this. Now this angle I would like to bisect or exactly cut with equally placed on either side. How do we do that? Using construction is how we're going to learn the first step of constructing the bisector of a given angle. So in order to do this, we have the different steps to be followed with. Firstly, I take a compass pointed at this end and I take some suitable radius. So fix the pointer of the compass out here and just draw an arc. Any arc which is of suitable radius. So take a compass and draw an arc. Now from the arc we clearly see that this arc cuts the two lines at 2 points, say P and Q. So let me mark this with P and let me mark this with Q. So I have 2 points which are formed for the arc cutting the two lines. Now let's take the pointer of the compass at P now. I move the pointer of the compass from A and put it at P. And then from here, with the same radius as taken there, I just cut, or you can take the other radius too. So we can take the different radius, but the rule is take the pointer now at Q and cut an arc with a suitable radius. Just cut an arc randomly, the piece of arc out here. Similarly, now move the pointer from P and put it at Q. So the compass pointer is now put at Q, but the radius is not moved. We take care that the screw is tight, because if the radius moves, the whole construction goes wrong. Remember, when we use the compass, the safest precautionary measure is to make the screw tighter so that the compass doesn't move along the radius. So keeping that in mind strongly, let's take the pointer at Q with the same radius as taken at P and cut with arc, and then from the pointer Q with same radius cut another arc, so it cuts in this manner. So this is how the arc cuts from Q, and this is how the arc cuts from P. They intersect at some point. So here is the point what we get. Now I have a point A and I have a point of intersection of two arcs which are joined by using the ruler. So join these 2 points using the ruler. Then I get something like this. This is how I get a line. And this line exactly makes equal angles theta and theta by this line. That means this line is the bisector of the given line. Let me take this as L. This is the bisector of the angle BAM or angle BAQ. So this is the bisector of angle BAQ as taken here. Is how we construct the bisector of a given angle. For any angle, the bisector can be constructed. So let's see each of the properties listed out in constructing the angular bisector AL. So here the rules come that firstly, draw an arc from A with suitable radius. So draw an arc from A with suitable radius. The arc which is drawn cuts the two lines at P and Q is what we have noted down. So mark them with P and Q where the arc cuts the 2 points. Thirdly, draw an arc from point P with suitable radius. It can be any radius suitable to be convenient to draw. Next, this point is very important. I draw an arc now from Q. So draw an arc from Q with same radius as this. This is very important. So I draw an arc from Q with same radius as the previous suitable radius. So therefore the two arcs meet at M. The two arcs meet at M, the point M, and then the next point is join AM. So I join AM and extend then. After you get this, that implies AM is the angular bisector for angle BAQ is how we understand the concept. AM is the angular bisector for angle BAQ. Rule 1, draw an arc from A with suitable radius. Rule 2, the arc cuts the two lines at P and Q, the line AB at P and this line at Q. Draw an arc from P with suitable radius. Take a pointer at P and draw an arc with suitable radius. Next, draw an arc from Q with same radius as the previous one. So do not move the radius of the compass, but from Q, mark with the same radius. The two arcs meet at M, as can be clearly seen here. Then join AM and extend. The line AM is nothing but the angular bisector for the given angle. Angular bisector and its construction process. Perpendicular bisector. Now that we have discussed about constructing the angular bisector, let's see now how a perpendicular bisector can be constructed for a given situation. Construction of perpendicular bisector is the session for today. To construct the perpendicular bisector of a given line. To construct the perpendicular bisector of a given line. Now that we know that a perpendicular bisector is a line which exactly passes through the midpoint of the given line and which is perpendicular to the given line. To recap with, a perpendicular bisector of this line AB would be nothing but a line which is exactly passing through the midpoint and which is perpendicular. Is how we understand the perpendicular bisector. So this line is referred as perpendicular bisector because this line passes through the middle point M of the line AB and this is perpendicular to the line AB. So let's see how perfectly we can draw this kind of a line for any line AB given out there. This session is about construction of perpendicular bisector of a given line. I have a line AB which is given with its endpoints A and B. Now let's see how we can draw the perpendicular bisector. The first rule what we make in perpendicular bisector is I take the compass at pointer A and then by fixing the radius I take the precautionary measure that the radius is more than half. That means I cannot take the radius which is less than half and cut an arc. I always take something till here or here or here which is approximately more than half. So putting the compass pointed at A, I take the radius more than half and then cut an arc. Something like this. Similarly, I do not disturb the radius, but with the same radius, I put the pointer now at B and then from the compass, I cut an arc. That's how we get the two arcs cutting. Is how we get the two arcs cutting. So now we have the arc which is cut on both sides and this is the way I get the two arcs from A and B meeting at this points, say P and Q. They meet at P and Q. Let me join the 2 points P and Q using a ruler. So when I draw this with a ruler, I get a line which is exactly in the middle and perpendicular to AB. Is how the construction of perpendicular bisector defines. So here we get a line which is exactly passing through the middle point of AB and which is perpendicular to the line AB, cutting at 90 degrees. Therefore, this line which is obtained by taking the compass more than half and cutting the two arcs, we get perpendicular bisector. So here comes perpendicular bisector. PQ is the perpendicular bisector which is obtained through the construction process. Let's see the rules in step-by-step process. The first rule is, for the given line segment AB, we take the compass with radius more than half. Using compass, cut an arc from point A such that its radius is more than half of length AB. This is very important. This is taken as precautionary measure, because if you don't take the distance more than half, the two arcs never cut, and there's no question of forming the perpendicular bisector. In order for the two arcs to cut, the rule is that the arcs must fix with the radius more than half. So here, using compass, cut an arc from point A as we get here, such that its radius is more than half of AB. Cut an arc from A on either sides of AB, because we don't cut the arc only on the top but on either sides of the line AB, here and here. Therefore, using compass, cut an arc from A on either sides of AB such that its radius is more than half of AB. Next, cut an arc from B on either sides of AB with the same radius. Now here I do not disturb the radius from A, but with the same radius I repeat the same process, but now from point B. Cut an arc from B on either sides of AB with the same radius. The two arcs meet at P and Q. As can be seen, the two arcs meet at P and Q. Now, join PQ and extend on both sides. I join PQ and extend on both sides. Therefore, I observe that the line PQ as obtained is the perpendicular bisector of line AB. Is how we understand PQ being the perpendicular bisector of the line AB. Perpendicular bisector constructed through the following rules. Now that we have seen the construction of an angular bisector and the perpendicular bisector for given line AB, now let's see how we can construct an angle or a perfect angle of 60 degrees using the construction properties. This session is about constructing perfectly an angle of 60 degrees. To construct an angle of 60 degrees. So let's see how we can construct an angle of 60 degrees. But the rule here is Interestingly, if we have a protractor, we can directly construct, because in a protractor we have the 60-degree angle which can be identified. But this session we are going to construct an angle of 60 degrees. More interestingly, protractor is not allowed. That means without the help of the tool called protractor, we will try to construct an angle of 60 degrees using strictly the construction properties, proudly in mathematics. So let's see how to construct an angle of 60 degrees without using the protractor. So here I take a line segment AB. Now at this point A, I would like to construct a 60 degrees angle. So let's see how we can do that. So in order that I construct an angle of 60 degrees, I just first put the compass at A and draw an arc of suitable radius. So here I draw an arc which cuts the line AB at some point D with some suitable radius from the compass. Now with the same radius, without disturbing the compass, I now put the pointer at D and cut with the same radius. So with the pointer at D, I cut with the same radius, and the new arc which is formed clearly cuts the old arc at this point, say some C. So here I have a point C where the new arc cuts. Let me just extend this line and then I get this line which cuts here at say C is extended further. So here the angle which is formed at A is exactly 60 degrees, perfect, without using the protractor. So some of the angles can be constructed without using the protractor by using simple techniques of geometrical properties of cutting an arc with the same radius, cut an arc and join the two arcs, join the 2 points, and then we get 60 degrees. So here is what I get, 60 degrees. So let's see the rules in brief. The first rule is draw an arc of suitable radius from point A. Which cuts AB at D. As clearly seen, this cuts AB at D. From D, draw another arc with the same radius. From D, draw another arc with same radius. Which cuts the older arc at point C. Clearly this cuts the older arc at point C. Now here we have 2 points A and C which are joined and extended. Join A to C and extend the line. So we get here a line which is this. Therefore, angle BAC is 60 degrees. angle BAC is perfectly 60 degrees. So whenever we want to draw an angle of 60 degrees, we use this simple technique, which helps me in perfectly drawing an angle of 60 degrees. More importantly, without using a protractor, is how I understand the property concept. Now let's see some properties, the construction of triangles with certain conditions. So now that we have learnt how to construct an angular bisector, how to construct a perpendicular bisector, and how to make the different properties as discussed in the construction process. So let's see now how we can draw a triangle whose base is given, whose base angle is given, and sum of other two sides are given. So this session is about the construction of a triangle. To construct a triangle whose base and base angle and the sum of other two sides is given. So let's see how we can construct a triangle whose base and base angle are given and the sum of other two sides is given, are all given in the process. So let's see this special case. So here I have a base AB of certain length. So I take that given length using the ruler and I draw a line segment with that fixed measurement using a straight ruler. So once the line segment AB is given and drawn out here in the plane, next is the base angle which is taken. Say my base angle at A is given, so I make an angle using the protractor and then I get the angle out here. So here is the base angle. So once I get the base angle using the protractor pointed at A, then after this let's take the sum of two sides. Say in this case I draw a rough figure A, B and C. In this case this angle and this distance are given, and so here length AB is given, angle BAC is given, and sum of other two sides, that is AC plus BC, is also given. Is how we have all the three things given. So let's see how we can construct a triangle just with the base and the base angle and sum of two sides which is given. So what I do is AC plus BC, the sum of other two sides which is given, is taken as the measurement. Say if this is given to be 14 centimeters, I take the compass with the length of 14 centimeters and cut an arc. So here I cut the arc with the distance of AC plus BC. So that distance is cut an arc and it cuts this line at D. Then I join D to B. I just join the two lines from D to B. Then I take the angular bisector at B. So we know how to draw the angular bisector as taken in the previous case. So I draw the angular bisector at B by cutting an arc, and then I get this cutting at C. So here clearly we say that the triangle which is obtained here is the required triangle. So I clearly get this to be a triangle which is ABC, which is obtained here. So this is the triangle. Triangle ABC is the required triangle. As how we get when there's a base given, base angle given, and sum of two sides AC plus BC is given. I first draw the line AB, the base, and then make an arc or make an angle with the protractor, and then take the measurement of AC plus BC. From A, I cut with the same measurement, it cuts at D. I join DB, then I get a bigger triangle ABD. Then I find the angular bisector at B, which cuts this line AD at C. So this angular bisector which cuts at C will form a triangle ABC as represented by the dotted region. And this dotted region is the triangle ABC and is called the required triangle. Given the base and the base angle and sum of other two sides, a triangle ABC can be constructed using this process. Construction of triangle ABC. Now that we have seen how to construct a triangle with the base and the base angle as given out there, now comes the question of what if the sum of sides which was given in the previous case is now reduced to difference of two sides which are given. This session is about constructing a triangle whose base and a base angle is given and the difference of the other two sides is given. Let's see the session. So the session is about to construct a triangle whose base and base angle are given and the difference of other two sides is also given. So let's see how we can construct a triangle if there are difference of the other two sides which are given along with the base and the base angle. So let's see the construction process. So here the base which is given is taken out here. AB is the base, and after making the base AB, I have the base angle which is taken out here. So at A, let me say I have the base angle which I draw using the protractor, and then I get this ray. Now, the difference of two sides, say for example, if I take the construction diagram as a rough work, ABC, this is given, or this is A, B and C, and this angle is given, then the difference of two sides, say AC minus BC, is given. Now this I take it as case 1 because there is a possibility that BC minus AC also might be given. That is, here the case 1 is that AC is assumed to be greater than BC. There is a possibility for AC to be less than BC, which we take exclusively as the second case. So the first case dealt with constructing a triangle is that this measurement AC is assumed to be greater than the length BC. So in this case, the value which is given out here for the difference of other two sides is taken on the compass and we cut the arc. So here we cut with the same measurement of the value as given in the difference of two sides, and using the compass I cut out here. So this cuts the ray at point D, and now I join BD. So after I join BD, I get a straight line which is like this. So for this line BD, I draw the perpendicular bisector. So we all know how to draw the perpendicular bisector. Take the pointer, take more than half and cut an arc. I get a perpendicular bisector out here. So I get this to be a neat ruler and a diagram. So here is D, and here I want to draw the perpendicular bisector. So here, let's say here is the perpendicular bisector for this line. Which cuts exactly at certain point. So let's say this perpendicular bisector meets the ray at A or at C. So here this is assumed to meet the ray at C. So I get the point C cutting the ray at point C. I join BC with a straight line. And then I get a triangle ABC, which is clearly obtained as given by the dotted line. This is how we get the straight line. The dotted line represents the triangle ABC, which is obtained where the base angle and the difference of two sides is given. We can construct a triangle ABC. Is the required triangle is how we identify the triangle ABC with the base angle and the difference of two sides as given. With the case 1, AC assumed to be greater than BC. Now let's see how we can construct a triangle whose base angles are given and whose perimeter is given. This session is about constructing a triangle whose two base angles are given, not the third base angle, but only the base angles are given, and the whole of the perimeter, that is, sum of all sides of the triangle, are given. To construct a triangle whose base angles are given and the perimeter is given. So let's understand what are the given things through which we can construct. So here if I assume a triangle, we have only the base angles which are given, but we don't have the length. So we cannot assume the length, but we assume that the base angles are given, and AB plus BC plus AC is given, angle A is given, and angle B is given. Is how we have all the three different things which are given in the triangle ABC. So let's see how we can construct a triangle whose base angles are given and the perimeter is given. So let me take the perimeter length which is given out here as the base. So I take the base initially such that this is nothing but the length xy is such that it is the perimeter of the triangle. So I draw a line segment base xy, which is nothing but the perimeter of the required triangle ABC. Now from x and y, I draw the base angles A and B, which are given to be the same as I draw here. My base angle A value is drawn as an angle out here, and my base angle B, which is drawn from y, is drawn from here. Now from this we draw the angular bisectors of x and y. So once we get these two angles, then I draw the angular bisector x at x, and I draw the angular bisector at y. At y. And these two angular bisectors meet, say, at point A. That means the angle which are equal cut at the point A. Now, after I get the point of intersection of the two angular bisectors at x and y which meet at A, now I take the perpendicular bisector for XA. So let me take the distance XA or AX and draw the perpendicular bisector. And let me take the perpendicular bisector of AY, say, which cuts at B and C. So here the perpendicular bisectors from AX and AY meet the baseline XY at B and C, as can be seen clearly in the diagram. So I get 3 points ABC which are joined. So I join AB and AC and I get ABC, which is a triangle. So here I get the required triangle. So ABC is the required triangle. Triangle ABC is the required triangle. Is how we construct using the angular bisectors and the perpendicular bisectors. So if base angles are given and the perimeter of the whole triangle is given, that is sum of all sides of the triangle is given, we can construct a triangle using this process. Take the base with the measurement of the perimeter of triangle. From X, draw an angle equal to angle A. From Y, draw an angle equal to angle B, and then draw the angular bisector of X and from Y, draw an angular bisector of Y, and then they meet at point A. So from XA, draw the perpendicular bisector, and for line segment AY, draw another perpendicular bisector. Clearly, the two perpendicular bisectors meet the baseline XY at B and C. The points of intersection of the perpendicular bisector and the baseline XY are B and C. Join AB and C, which forms a triangle as represented by the dotted region. So in this case, triangle ABC is the required triangle, which can be constructed only if the base angles are given and the perimeter is given. Constructing a triangle ABC with the rules.